In the final years of World War II, as armies clashed across Europe and the Pacific, some of the deadliest moments of the war did not come from enemy fire, daring ambushes, or strategic brilliance. They came from something far more unexpected: a catastrophic engineering miscalculation. A single flawed assumption, a single overlooked detail, a single mistake so massive in scale that it cost thousands of lives in a matter of hours. This is the story of the fatal engineering error of 1944, an event buried under decades of classified reports, conflicting testimonies, and political silence, a disaster that reshaped military safety standards, a mistake so devastating that even today, historians struggle to trace its full human impact. For the soldiers who lived it, the event wasn't a technical oversight or an academic exercise. It was terror, chaos, and death. Today, we uncover the painful truth behind one of the war's most lethal engineering failures. By 1944, the war had reached a breaking point. Front lines shifted violently, supply routes were stretched thin, and the demand for faster production of weapons, ammunition, fuel, bridges, and vehicles pushed engineers to their absolute limits. Factories operated around the clock. Design changes were rushed. Safety protocols were ignored or rewritten to save time. Every nation involved in the war felt the pressure. Decisions that would normally require months of testing were approved in days, sometimes hours. Military engineers were not just building machines. They were fighting deadlines, political expectations, and the brutal speed of war. In this environment, a single mistake could kill dozens. A larger one could kill hundreds. And in 1944, one mistake killed thousands. To understand the mistake, we start with the situation on the ground. During late 1943 and early 1944, battles across Eastern Europe intensified. Armies advancing across rivers, marshes, and unstable terrain needed temporary bridges that could support tanks and heavy vehicles. Existing military bridges were too slow to assemble, too heavy to transport, too fragile under artillery fire, too narrow for new tank designs. Commanders demanded a new type of lightweight, fast-deploying, high-load capacity bridge. Engineers began working on a structure based on modular steel units, easy to transport, quick to assemble, and strong enough to withstand the weight of armored divisions. On paper, the design was brilliant. In reality, one single flaw would make it deadly. The bridge design relied on a new type of welded steel support beam, chosen for its speed of production and its lighter weight. But in the rush to meet deadlines, one critical detail was overlooked. The steel alloy weakened drastically in cold temperatures. Standard testing occurred at room temperature or mild conditions, but the battlegrounds of 1944 were anything but mild. Harsh winter winds, freezing river crossings, sudden temperature drops, heavy loads from tanks and supply trucks. Under these conditions, the steel beams behaved unpredictably. Instead of bending under stress, they snapped. And when they snapped, they shattered catastrophically. It was a textbook case of brittle fracture. But at the time, the concept was poorly understood. The mistake wasn't intentional. It was a fatal oversight created by the perfect storm of wartime pressure. The new bridge system, still untested in real combat conditions, was shipped to multiple divisions in early 1944. The units who received it were told it was stronger, it was safer, it could hold tanks, it could be built in hours. The engineers who designed it believed this was true. They didn't know their design would become a death trap. By the spring of 1944, dozens of these bridges were deployed across active battle zones. Some worked. A few even supported large convoys, but others cracked under pressure, collapsed without warning, and in one horrifying case, failed so violently that soldiers described the sound as a thunderclap ripping through steel. This failure became the center of one of the deadliest engineering disasters of the entire war. It was early morning, 1944. A temporary bridge spanned a major river crossing, vital for moving reinforcements and medical convoys. Soldiers of multiple units prepared to cross. Infantry medical teams, supply trucks, an armored column trailing behind. The weather had turned brutally cold overnight. Freezing wind swept across the water. Metal surfaces were coated in frost. The first group crossed without issue. The second convoy followed. But when the third wave began, heavy equipment, vehicles, and personnel all moving at once, the bridge reached its critical limit. One bearing slipped out of alignment. A steel beam, already stressed from the cold, buckled. Then another. The collapse was instantaneous. The entire center span snapped in half, shattering under the weight. Dozens of soldiers, trucks, crates, ammunition, and equipment plunged into icy water. Vehicles sank within seconds. Men weighed down by gear had no chance of swimming. The river became a swirling mass of debris and bodies. Rescuers on the shore could save only a handful. The rest were swept away or dragged down by equipment. In less than 1 minute, over 320 men died. And this was just the first collapse. News of the disaster spread quickly among commanders, but not fast enough. Multiple bridges of the same flawed design were already in use across other fronts. Within 2 weeks, another bridge collapsed under a tank column. A third snapped under a field hospital evacuation convoy. A fourth failed during a nighttime crossing. Each collapse killed dozens more. In total, historians estimate the death toll exceeded 1,700 soldiers. The engineering mistake was not just serious, it was catastrophic. Commanders demanded answers. Teams of engineers, metallurgists, and investigators examined. Broken steel beams, recovered bridge fragments, temperature logs, load calculations, assembly reports. The verdict was clear. The steel alloy used in the bridge design became dangerously brittle in cold weather. The engineers had not tested the beams at sub-zero temperatures. Factories had cut corners. Command units had approved deployments too quickly. The collapse was not sabotage, not enemy action, not misuse. It was a preventable engineering oversight, one that cost more lives than many full-scale battles. The military leadership faced an uncomfortable reality. This disaster was not caused by the enemy. It came from within. To preserve morale and avoid political backlash, many reports were buried, redacted, reclassified, lost in bureaucratic layers. Families were told their loved ones died in action without specifics. Bridge failures were attributed to enemy shelling, surgical damage from combat, sudden environmental collapse. Only decades later, when classified documents were declassified, did the truth emerge. The disaster changed military engineering forever. New protocols required cold weather testing for all structural materials, stress simulations under extreme loads, reinforced beams with mixed alloys, stricter quality checks, slower deployment of new designs, better communication between field engineers and factories. Modern military bridges, quick-deploy steel spans used worldwide, exist because of the lessons learned from the tragedy of 1944. Thousands of soldiers died, but their deaths forced an overhaul that would save countless more in later decades. The story of the fatal engineering mistake of 1944 is not just about steel beams, broken bridges, or design flaws. It is about the human cost of rushing decisions during war, about the lives lost because one detail, one calculation, was overlooked. War is filled with battlefields, bullets, and strategy. But sometimes, the deadliest enemy is not the one you see, but the one you build unknowingly with your own hands. The thousands lost in 1944 never knew why the bridge beneath them failed. They trusted the engineering, the design, and the command that sent them across it. They deserved better. And today, their story finally comes to light.